Hello. Today we're going to demonstrate the difference in how the GS4 Southern Pacific 484 engine made by MTH and how it operates on the standard NCE Power Cab that is rated as 1.5 amps, and now that we've bought the NCE Smart Booster 5 amp, exchanged it on the layout, the difference it makes in the operation of the locomotive. We're going to let you see the difference, and then you can make your comments. So the first thing we're going to do is we're going to plug the cable into the power cab, and it will start up, and you'll notice that there's a red light that indicates the track is getting power. So what you have installed here is you have a wall wart that's rated at 1.5 amps. Then you have your connection panel that has the straight flat wire that plugs into this port. And then you've got a red light that indicates that power is going to the track. And we're going to demonstrate how the MTH GS4 operates on the power cab. So first we apply some power, and that starts up the system. Turn on the lights. And where we've been having a problem is on the upper level. We have a problem after we go by the station, and then at various other locations where a heavy load is put on the train. It's starting out just at idle like that. It's pulling 0.66 amps, which is basically half of what the power cab can put out. So let's watch the engine run and observe its performance issues, and then we'll compare it, and I'll show you how easy it is to hook up the NCE Smart Booster, and then we will let you see the results of that exchange of equipment. Notice when you blow the horn how the train stops. That's because the amperage jumps up to 1.1 amps just by blowing the horn. So we're running on 1/28 of speed steps, and we're going to increase the speed to 35 because that's where we were demonstrating our problems last time around. So we'll use the same data points to see the operation. At the same time you blow the horn, the engine locomotive slows down. So now we're going to check the speed through the AccuTrack 2 speedometer. We're set at 126 speed steps. We're pulling 1.15 amps. Miles per hour, 9.8 miles per hour at full throttle. Now we're going to show you how easy it is to change over to the NCE Smart Booster. So first off, we'll take the coil cable that came with your original NCE Power Cab that you didn't use for the Power Cab because it's not a power rated cord. And we're going to plug it into the bottom of the NCE Power Cab. Of course, you have to turn it around the right way. And it clicks in, so. Notice we don't have any power yet, right? So, now what we've done is we connected the other end of the coiled cable to where just underneath where it says SB5. Should be able to see that in there. Zoom in a little bit more. And then there's a power supply that's a 5 amp power supply that I don't know if we can see it or not, but it's right underneath there if you see the green light. And so we first need to plug in the track power. So we unplug the track power from the original installation, and your track power is connected via this cable right here. Then we're going to lift up. If you see where it goes in right there, whoops, turned it loose, and you plug the track power in like so. Okay, the track power is plugged in, and then somewhere down there, right there, to be exact, this is our plug from our power supply. We plug it in right there. And as simple as that, with the red light coming on, we now are ready to operate on the 5 amp power supply. So we let that down. And now, as you can see, we have our information on our display. We're going to recall to engine number 3. Okay. Now we're going to turn on the track power. Track power is on. Now, one function we lose with this installation is we don't get to see the amperage that the locomotive is pulling anymore. So with that, let's now focus back on the locomotive. You should be able to see this on speed step 128. A brief recap, we hooked up the track leads to the track output. We plugged in the new power supply for the Smart Booster, 5 amps. Then we hooked up the coiled cord to the Power Cab handheld, and then also to the right input in the Smart Booster 5. So with that, we're going to start off. We're putting the handheld into 128 mode. Speed step 1. Notice the engine does not stop when you blow the horn. speed step 2, but 3, 4, 5. We're going to see how it goes through the speed trap. We're going to go back to speed step 1 as it approaches the speed trap. We're slowing down to speed step 1. So 1.9 scale miles per hour. Now we're going to speed up to the 35 that we used with the other power pack to go up the hill and by the upper station. So we're going to accelerate out of the yard. Nice smooth acceleration, no stuttering, no starting over of the sound. We're now at 35. Speed step, which is the same speed that we operated previously the power cab on. We're going to look up at the station and see the performance as it goes by the station, noticing for any slowing down, stopping, or loss of sound, or stuttering. No problems whatsoever. We're now going to go back to the speed trap. We're going to ratchet the speed up to maximum speed of 126 speed steps. And we'll see how the locomotive comes by. .64 scale miles an hour. And here it's going to come through the speed trap for a second time. .55 miles an hour. .9 miles an hour, which if I remember correctly is the same as it was going forward through the trap. So what we seem to have proven is that the MTH engines require more amperage to operate all their functions. If you noticed on when we changed over to the smart booster, the engine no longer slows down when you blow the horn or ring the bell. It doesn't slow down up at the upper station like it used to, and it goes through the speed trap. It goes down the speed trap in a nice smooth fashion. So it sure seems to be that on the MTH engine, and I have 3 of these that all do the same thing. Actually 4, 5 to be exact. 6. So that's 6 total that all have the same issue as far as they just need more power. And so with that, also we're going to do a test here in just a second. We're going to run the Broadway Limited F-7s through the speed trap I got a sneaky feeling that we're going to see a higher top end than what we've typically seen from Broadway Limited Rolling Thunder engines also. So we're going to get that set up and I'll be right back. These are the Broadway Limited Rolling Thunders F7s, the most recent ones that they've released. We're on 128 speed step. This is on the 5 amp Smart Booster by NCE, basically doubling or almost tripling the amperage that I had available before now. So we're going to go 1 speed step forward. So through the speed trap, the F7s at speed step 1 of 128 is 2.5 miles an hour. Now we're going to put them up to maximum 126. And let's see what they're doing the next time they come around to the speed trap. We'll also notice if it slows down as it goes past the station. Scale miles per hour. I've never had an engine run that fast on the way out. We'll see what it does on the second lap. Scale miles an hour. Well, the men at the shop are totally surprised on how fast that freight came through. The yard masters probably want to be a little bit upset because of the high rate of speed. So I would say that this test concludes that MTH needs more amperage to perform properly, and also Broadway Limited, and I would guess all benefit from the extra voltage and amperage that's provided by the NCE Smart Booster 5 amp. I hope you've enjoyed this review, and I guess you can take away from it what you want, but I see a definite improvement in operation, and really the operation improved just by exchanging the power supply, and the only thing that's changed is the installation of the 5 amp Smart Booster by NCE. Have a great day, and if you'd like, please make comments and subscribe. Till next time, happy railroad.